I'm Michael Bolton. I've been a tester for 63 years because we all are born testers. It's just over the years, school and socialization try to convince us not to be testers. I want to pause before I even get started to note something that came up in a podcast, an interview that I was examining the other day between my friends, James Bach, who is co-author of this material and author of the rapid software testing methodology, and our friend Keith Klain, who has been buying and selling and managing testing services for the last 25, 30 years or so. One of the questions that came up from Keith to James was, what do you think are some of the major misconceptions about rapid software testing? And James says probably the number one is that we're opposed to tools. We're opposed to automation. We don't like tools. And nothing could be farther from the truth. Nothing could be farther from the truth. We both started, James and I, in this daffy business as programmers. James was an assembly language programmer for 6502, Commodore 64 machines. I was a database programmer really early on. I take code and the use of tools seriously. We are not opposed to automation. What we are opposed to is shallow and thoughtless use of automation. We're opposed to fixation on automation because any kind of medium, any kind of tooling accelerates and extends and amplifies and enhances, enables human capabilities in some form. But tooling also does that irrespective of whether our capabilities are good, our capabilities are bad. So if we do bad testing, tools can enable us to do bad testing faster and worse than we've ever done it before. If we're virtuous, if we're wonderful, then tools can help us to do good testing in wonderful ways. But there's a catch, and that is, as testers, we've got to be skeptical about everything. It's our job to do that. Now along comes AI, which has been around actually for a really, really long time, easily since people were taking degrees in it in the 1980s and 90s. It's not a new thing. But now people are coming along and saying, oh, they hate AI. I don't hate AI. I mean, why wouldn't we like it? Look, you're an expert advisor in software development. Who are the top two experts in testing as the enactment of critical thinking focused on software-related risk? What's not to like about this response from ChatGPT? James Bach, Michael Bolton, there we are. Thank you, AI. I don't hate AI. But I don't like recklessness. I don't like bullshit. That is, a speech uttered with reckless disregard for the truth. I do not like fakery. I do not like software that has been negligently tested. I do not like hype. I don't like marginalization of human beings and human skills. I really don't like obsession with stock market value over value to society. I don't like parasites. And I don't like Elon Musk. So there you go. Whoop, oh, hang on, skipped over that a little too quickly. Got to be clear on what testing is, because I will argue that testing cannot be automated. Activities within testing can be automated, but not testing itself. It's like chopping. Chopping is a part of cooking that can be automated, right? We can use tools to chop, and we can even use machinery to help us chop. But cooking is a social process. It involves many things other than chopping. It involves, among other things, deciding what we're going to put on the menu, deciding how we're going to serve it, how we're going to present it, decisions about nutrition, decisions about whether our guests, some of whom might be vegan, or some of them who might be Muslim, or some of them might be Jewish. And we've got to decide when we're cooking, we've got to make decisions about what matters to people. And it's a very common pattern in software development and software engineering to forget that we're here to serve people. So, testing for us is evaluating a product by learning about it through experiencing, exploring, and experimenting, which involves a whole bunch of other things. The ones I want to focus on are risk analysis and critical thinking. Those are the two things that are at the core of testing. Testing is the enactment of critical thinking about the relationships between software products and to some degree software projects and people and the things that people value. So that's what we're actually all about, not just checking the output from the functions of a product. But a lot of people suggest that AI is going to change everything, just like they suggested that blockchain was going to change everything, and just like they suggested that big data was going to change everything, and just like they suggested that the Segway was going to change everything. I rode my first Segway here in Wellington. When was it? It was in the early teens or the late aughts or something like that. This was my first Segway ride. Significantly, I haven't read on a Segway since, but it was a big thing back then. If we're going to think critically about AI, if we're going to consider the risks of AI and the risks of using AI in our own work, we got to understand a few things. First of all, any kind of software can be marketed as AI. AI is not actually an engineering term. It is a marketing term. And it's a term, like many other things associated with the AI world, it's been something that's been co-opted from research and turned into marketing. That's okay as a metaphor. Training is a metaphor. A machine learning is a metaphor. The learning part of that is a metaphor. And metaphors are fine. But as Richard Lewontin quoted, although it's not clear where he got this from, Norbert Wiener, who was at the center of the cybernetics movement in the 1960s and 70s and so on. Norbert Wiener, according to Lewontin, said the price of metaphor is eternal vigilance. He was paraphrasing I think Patrick Henry, who said the price of liberty is eternal vigilance. The price of metaphor is eternal vigilance. So any kind of software can be marketed that way because it's doing something that presumably a human with reasonable degrees of skills could do, at least in theory, given time and resources, and it can do that real quick. Now, the first computers were marketed as electronic brains. That's a metaphor. And Shazam, SoundHound, I use SoundHound, and in fact, the thing that made me want to get an iPhone, the killer app for me for the iPhone, or the one that drew me in, was Shazam. Mary had an iPhone. We were in a restaurant one day, in a little pub on College Street in Toronto, and there's a song on the radio, or on the PA. What is that song? And Mary says, oh, I can figure it. Holds it up. Miracle. Magical. But there was nothing really even associated with machine learning about that. There was a lot of fast Fourier transforms and huge databases with very fast hashing algorithms that could pluck up the song, and it was magic. But you know, in my mind, I was thinking, okay, there's some people in India or the Philippines somewhere who are listening to this song really quick and they're looking it up, or maybe they've been immersed in the culture of pop music and they were able to pull this stuff up right away. Does it even matter that they're AI? No, it doesn't matter. It doesn't, the technology shouldn't matter to people if it's reliable and useful. And then I was having a chat, I think, with Tim just beforehand, when, these things can get it wrong. Yeah, sure they can, but there's not a whole bunch at stake if they get it wrong. On the other hand, what about these self-healing automation tools? What about those tools that if they get an unhappy result, a red result, they try it again a few times, and then we go to sleep on that? That's the problem, because what a red result shows us in an automated check or a procedure, a part of a test procedure that includes a checking some output from some function, if that runs red, I want to know about it. Even if the tool can repeat the action and find some other way of getting to the button that it's supposed to press, even if the tool can do that, I want to know about it, because a red result at any point is an indication to me there's something about the product or the test code or the environment or the relationship between any of those things that I haven't got right. That's what it's reflecting. That's what that red result actually means. There's something that's not right. Maybe it's only intermittent. I still want to know about that. I still want to know about that. So I don't want a self-healing a tool, because if it's self-healing, I want to know what the disease is. Another thing to consider is that any product that's sort of AI-based, it's not entirely AI. First of all, there's a lot of data that goes into it. There's a lot of training data and a lot of validation data. This is a very rough sketch, but there are things that process the data that's going in as somebody makes a request of it, and there's stuff that post-processes the data coming out, and then in the middle, there's this big black blob that's presumably some kind of machine learning model, which has been metaphorically trained by having a whole bunch of data put into it, and we look at the outcomes, classification, searching, or sorting stuff out, categorizing things, making so-called predictions. If we put this thing in, what's going to come out? When it comes out, humans make a decision about whether it was the right thing to come out or not. Now, sometimes that is we make the decisions and we tune the model to more closely reflect the decision, or we filter the output in some kind of way, and those things are actually not too hard to test. Not too hard to test because they're not mysterious. People write code that filters the output from a machine learning model, and sometimes that provides useful kind of corrections when it gets stuff wrong, when it stumbles. And that sort of stuff is analyzable, testable, checkable, though, because that part is written deliberately with human intention. But the black blob in the middle, that was created by throwing a whole bunch of data at a whole bunch of algorithms and then plucking out the algorithm that seemed best to fit the data. But there's a catch. The data that it seems best to fit always comes from the past. And it all comes from data that has been thoughtfully or thoughtlessly selected from all the possible data in the universe. What were the processes that went into the selection of that data? That's a question that's kind of germane, and that has a profound influence on what comes out of it, because we got these problems associated with that black ball. We'll tell you about those in a sec. The black blob might help when we know about the forms of AI that are being applied. Sometimes they're rules-based, symbolic decision trees that we've had forever and ever in expert systems. Sometimes they're based on connectionism, neural nets, backpropagation, learning from data, and sometimes that's supervised, and sometimes it's unsupervised, and sometimes it's attuned with human feedback. Then there's evolutionary models, there's Bayesian classifications that are made probabilistically by looking at various statistical patterns in the data. There's analogizing. There's generative systems that combine outputs or combine aspects of each one of those things and then produce stochastically based on some probabilistic model, some output that is in some sense novel, new, not exactly like it was before. So the question we have to ask is, what part of the system is software as usual, and what's the AI bit? I'm talking about any context in which we might be using or testing AI. We've got to understand the system. As testers, our obligation is to identify risk and to think critically. So a part of that process is figuring out what's involved here. So there's this list of things I got from a book by Pedro Domingos called The Master Algorithm. And he basically outlines these categories, most of these categories. There's a really, really cool book, about a year old and a bit now, by Simon Prince, called Understanding Deep Learning. And I'm still wrestling my way through it because it's a good deal more technical and a good deal more mathematical. But it is beautifully done. A little side issue. It costs probably New Zealand dollars north of 150 bucks. Whoa, kind of hard to do. Well, I paid the Canadian equivalent of that, about $120, and it comes in and it's this beautiful, it's a tome, but my goodness, it's a beautifully produced book. And then I found out a couple of months later that it's actually available online as a PDF. But I felt really good about sending 120 bucks, of which Simon Prince, as the author, might see like $6. But I felt really good about supporting the publication of this book. So if you download it as a PDF, well, you're welcome. I helped to subsidize Simon Prince's work. But it's a wonderful book, and I believe you I believe you could look at it. Now, when might AI be okay? I'm talking about all kinds of forms of AI, a little less about GPTs, but we'll get to that. When AI could be really, really good when its output is used for inquiry rather than decision making. If it helps us to frame better questions, if it makes us curious, if it helps us to prompt critical thinking, that could be okay. When it's used for discovery and analysis, when it's used for us to look over a set of data and produce insights like, that's interesting, I wouldn't have expected that. That could be quite useful. AI might be fine when there's no risk. Yeah, I don't actually care whether Shazam or a SoundHound get it exactly right. I don't have to. When it's my mother's medical care or my life savings being managed by some bank, then I care a good deal more. So loss, harm, damage, wasted time, bad feelings, diminished value of any kind. If that is at stake, then my concern for whatever the product is needs to be elevated. And that's no different than it ever was for any kind of software testing. Always like that. When risk is low, we don't have to worry about it. When risk is higher, and we do have somebody supervising the decision, and somebody in particular with the relevant and requisite expertise to evaluate whether the output is okay. If that output is being sent to a human for evaluation, and that human is the right kind of human to make that decision, no problem. When we want to jiggle ourselves, when we want to see something where, when pathological data is on the table, then an LLM could be great for that, because LLMs produce bad data on a regular basis. Maybe we want to feed that into some process for testing purposes. But if we want something reliable, we got to be a lot more careful. When the output, this is, I think, the best possible use of large language models and GPTs, lots of different kinds of classification systems, when we use them as lenses and as mirrors into what we're like, then I think they are super powerful because they are reflections of the data that we put in. They are reflections of the choices that we made on the validity of what's coming out and so on. I think that's really interesting. Here's an easy example of that. And it long before GPTs showed up. This is in 2018 or so. Two examples. One, Microsoft put out this thing called Tay. Don't know if you remember that. It was something that learned from Twitter feeds and then generated responses to things. And it took 24 hours for Tay to become a racist asshole. Why? Because Tay was trained on what Twitter is like. That's an interesting meditation on what we're like. Another example was Amazon's attempt to create a bot that would select exactly the right people to work at Amazon. What did it choose? White dudes in their late 20s, early 30s. Why? Because Amazon's patterns of hiring were based on that. Now, of course, very quickly it became realized, oh, geez, if we do this, this would be a really bad thing and a really bad idea. If we choose to learn from the fact that the model is reflecting what we're like, and we think about that in ethical and responsible terms, and make appropriate adjustments to the way we're thinking and behaving, then that's a fantastic use for AI. AI and autocorrect, it could go either way. All right, so a lot of questions we have to ask. Do we know how it works? And to a certain degree, we don't. It's a black box. How was it trained? What was the data? Was it the victim of a problem in PowerPoint that screwed up the font rendering? Well, as a matter of fact, yes, it might have been. Let's see if we can get that right. There we go. That's better. There's all the questions. Can it be wrong in subtle ways or random ways and still be worth using? That's a question worth asking. Is the work fast enough, considering that we have to supervise it and scrutinize it? Can we safely and legally provide data to the AI? What happens if some of the data gets sent up to a company that wants to use it for other kinds of purposes? These are questions that I think we should be asking. Oh, here's some more. Will we be able to evaluate its work? That's a big deal because these things produce enormous amounts of information. Or not information, let me say. Not information, text. We have to look at that and scrutinize it and decide whether it's information, whether it's reliable. How does using a tool change people's relationships to the work? Here's an example of that. There's an organization whose name escapes me at the moment. I'll have to reflect on it and remember it. But it's, GitClear is the name of it. And they've been doing analysis on programmer check-ins over the last little while. And they noticed something starting in 2023, that the number of check-ins by January 2024, I believe, had multiplied by 4. Why? Because programmers were loading stuff up into GitHub, and then we're realizing problems with it, and then uploading again. So the cycle of uploading, generating code, which they were doing with the GPT, presumably, uploading it to GitHub, and then suddenly realizing, ooh, my goodness, there's a problem with it. Well, that multiplied by 4. And it's even higher now than it was then. Finally, who's responsible when software makes an error? Because I can tell you one agency that is not responsible, and that's the software. Who's going to be liable when some algorithm drives into a crowd of school children? When you have the choice of driving into a crowd of school children and having the car drive itself into a telephone pole in order to save the kids, and you're the driver of the car, nominally. You're the driver of the car. How do you feel about buying that car now? How do you feel about the reliability of that decision? And how do you feel about when the car is out of control and going toward the school kids, your option is to kill yourself? That's how it should be programmed, isn't it? Shouldn't the car sacrifice the driver rather than the victims?
Is that a real world example, Michael, or is that hypothetical?
You want to find out? It is hypothetical. I'm just wondering, if you're going to be sitting in the car, where are you going to be deciding? Now, do you want to buy a self-driving car? Yeah, well, I'll think about it. Okay. So, do you know what they actually do? Here's a bunch of really useful references for those of you who are taking pictures. These three things in particular are really, really good for practically anybody, including testers, of course. For programmers, I found these two from Jessica Carr and Chelsea Troy to be super interesting and worthwhile. And Emily Bender and Timnit Gebru and I think it's Margaret Mitchell, although she had to change her name to Schmargaret Mitchell to avoid being tagged as a Google employee. And another researcher, Deborah Raji. Notice, by the way, that all of these people are women. Have you ever noticed that a lot of the people who are expressing doubt and concerns about the impact of AI on society, have you ever noticed that a whole bunch of them seem to be women for some reason, and women of color for some reason? I wonder why. Maybe it's because they have some experience with being marginalized in various ways. Now, mind you, in some senses, testing AI is like business as usual. I mean, to test a product or a system, we got to understand how it works. We got to have to learn and model the test space. We have to model and identify risk. We have to figure out how to cover the product with testing. We have to develop oracles, means by which we recognize a problem. We have to design experiments. We have to perform them. We have to evaluate the results. We have to tell a three-part testing story, that is to say, a story about the product and the problems in it. We have to tell a story about how we tested, and we have to tell a story about the quality of our testing work. And all the way through, we've got to embrace doubt. We've got to be the people who are talking about doubt, who are talking about risk, because the testers are the only people on the project for whom that is job number one. Everybody else sees risk and problems as a kind of side hustle. They might be concerned about it from time to time, but their primary job is building things and not worrying about problems in them, not so much. So what makes AI and large language models and GPTs problematic? How am I doing for time? 4 minutes. Okay. Algorithmic obscurity. It's not written by socially aware people. We can't fix machine learning models at their core deliberately because they're not programmed intentionally. We are dealing with social problems too. People wish that these things do things and they actually don't do them, and they're impossible to verify. They do insert themselves into the social realm, and that has big problems when we put a machine. Well, those of you who've watched Little Britain, how many have watched Little Britain? Yeah, computer says no, right? You've seen that. And if we delegate these things to decisions to computers, same kinds of problems that we always had. But now we ramp up the problem because we don't know how they actually work and we don't know how to fix them. We've got social aggressiveness and corporate defensiveness. We've got obliviousness to truth. That's a big problem. These things have no notion of what is true, what's false, what's right, what's wrong, what's morally defensible, what's immoral. But because they look like answers given by people, we invest into them sometimes, trust that we should not give to people, and we shouldn't give them to machinery either. And they're expensive to test. It takes a long time to review the results, and the results that we get from these things have subtle, hard to find, hard to notice errors, especially when we're super impressed by the stuff that it gets right. I commend to your attention if you use those words, large language mentalist, and look for Baldur Bjarnason, he will give you a wonderful thing in which machine learning models, GPTs especially, are like card readers, palm readers, people with crystal balls. They say something, and if it's true, or if you can make it true, you can think, oh no, it's not my father's name didn't start with M, but my grandfather's name started with M. That's probably what they mean. We fill that stuff in when we see a cold reader or a mentalist or something like that. I got lots to say about it, and I don't have time to say any of it. Here we go. Oh no, I don't want to do that. This is a clever Hans story, so I won't do that. I just want to show you a couple of examples of testing that we've done. Here's what we got to say. We got to say, hey, cool demo. But how much of it required us to steer the bot when it went off track? Here's something I did a little while ago. I wanted to get a bot. I wanted to get rid of some hidden files in a folder. So I said, how do I delete hidden files on Windows from inside a Ruby script? Now, if I did this in Python, I'd probably get better results because there's more training data related to Python, but it says, oh, no, it's straightforward. Here's how you can do it. Use the file class and its delete method. Okay, fantastic. Any Rubyists in the room? Any Ruby programmers? Yeah, I'd forgotten this. Ruby's file object doesn't implement hidden, right? It made the whole thing up. So I said, hang on. Ruby's file object doesn't, and of course it says, I apologize for any confusion. You're absolutely correct. My mistake. You got to use file stat. That's the thing. File stat is a special a library or a module in Ruby that does have the hidden method. Well, actually, no, it doesn't. It doesn't implement hidden either. Can I trust this to do it again every time for every situation like that? How about now? Now, this is a famous one because the AI fanboys will tell you, who cares about how many letters there are in the word strawberry? So count the letters in the word strawberry, and it gets it right. Look, there we go. Yep, those results are right. One S, one T, okay, good. Yeah, looks pretty good. All right, ship it. Or, if you're a tester, do it again. And it gives me a JSON object. There's the JSON object, but I deliberately misspelled strawberry. Will it get it right? Well, let's see. 2, 4, 5, 6, 7, 8. Yep, it got it right. But notice something subtly different. It didn't track the S as being capitalized. That's interesting. Except, what's this below? If I paste this into a JSON, it's going to come back as an invalid JSON because that stuff, when I hit the copy thing, that's going to be there and it's going to cause me trouble. So, I changed the prompt just a little bit in honor of my friend Wayne Roseberry. It counts and it gets the numbers right. Except the junk is still there. What's up with that? Here's the exact same prompt. Exact same prompt. This is a really important thing. Clear out the context window and do it again. Here's a difference thing there. Now it's separating the capital S's from the small s's. Now the AI fanboys will tell you, oh, here's one where there's actually a wrong result. Roseberry, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it gets the R's wrong in this one. So the AI fanboys will say immediately, well, come on. That's a trivial problem. This isn't a big deal. This is just about counting the letters in strawberry, isn't it? No biggie. Well, sorry. But if we want to generate reliable test data or do reliable analysis, what's it going to do with a more complex problem? Like this one. I was asked to review this book. This will be the last example, and I have plenty more. This is a book written by somebody who I actually consider to be a friend. I was asked to have a look at the book after it had been published. So there's a very straightforward thing, a very straightforward way to use AI in testing. JSON to SQL transformer, convert the JSON object delimited by triple hashes into a SQL statement that will create a SQL table to insert the transformed records into, and then create insert statements to add each record to a database. Check. See, you got to be careful with the prompting there. Check to see that the statement covers all the aspects of the JSON before outputting the results. Do I have to tell that to a human? No. And if a human does it, I discipline them. Or, I reprimand them and they learn from that mistake. Anyway, here's the example from the book. Cut and pasted it. My trial, that's the book. This is my first trial and this is my second trial. Notice that I did 2 trials. Varchar 255, 100, 50. Varchar 255, 100, 50. Different results for each one. Decimal, int, decimal. That's for pricing. Sort of interesting, huh? Additional needs. Varchar 255, 255, 100. 229 somethings, 229.00 somethings versus 229 somethings versus 229 somethings. Interestingly different, because this one here says decimal. And look at the output. This one here sort of kind of gets it right. That says decimal, and that is decimal. This one here says int, and it's an int. We got to take these differences seriously. Now you could say, well, hey, why not just trust them? I mean, we trust Python, don't we? We do. We trust Python because Python and languages and frameworks have a track record of reasonable reliability. Why? Because they are vetted by people. All right, got a question?
Yeah, do these differences make them invalid?
Do they make them invalid? No, they make them inconsistent. We say to the thing, well, this has to be a decimal, right? This has to be a decimal. Yeah. And it gives you the decimal, but then it might not correct this down here. See that up there? Because look, it got it wrong there and it got it wrong there. There's every probability in my mind. Oh, you can't quite see it? Just shuffle that way. This one specifies that it should be a decimal, and this data here doesn't. So I'm going to have to scrutinize this. And that takes a lot of work, because when you get output from these things, they very often produce enormous amounts of data. And it is of the nature of software that somewhere in there can be a bug that is rare, hidden, subtle, intermittent, platform dependent, context dependent, situation dependent. And 2 other things. Emergent. When we put well-tested components together, package them into a full-blown built application, even though those components themselves are wonderful, well-tested, robust, the interactions between them can present friction points where problems can happen. That's why we have to test the built product, because everything up until the point we got the built product, everything we know about the built product up to that point is a theory and a hope and a wish. So if we assume that putting together a bunch of well-built products, which is a great thing to do, don't get me wrong, it's really good to check the bits, to check the parts. But a whole bunch of parts put together do not necessarily mean a system that hangs together well. And that is why even after we've got a CI/CD pipeline that builds stuff really wonderfully, I would argue we need to get experience with and experiments on, and exploration of that built system before we inflict it on an unsuspecting world. I have lots more to say on this subject, and so thank you.